Yes. Okay, let's look at the motion in one dimension. As you remember, motion in one dimension, uh, for the first time, there are some important terms. For instance, speed and velocity. The difference between speed and velocity, speed is distance traveled over time, and velocity is the displacement over time. In other words, speed is scalar quantity, and velocity is a vector quantity. Okay, vector quantity. In addition to this, first of all, we are gonna study motion in one dimension. It is with the constant velocity. Assume that velocity is constant. Okay. If the velocity is constant, we can formulate it as velocity is delta x over delta t. Delta x is the displacement here, and delta t is the time interval. And if the velocity is constant, it has a linear change, linear rate of change. It has a linear rate of change uh, in terms of displacement time graph. Okay, its displacement time graph has an linear rate of change. Okay, and its velocity time graph. Just a second. Its velocity time graph is constant. Uh, as you remember, as you remember, uh, as you remember, uh, the direction of the motion is also important. Assume that this is point zero, and assume that this is a positive part and this is negative part. Yes, right now let's here is positive 100 and here is negative 100. Okay, and assume that with constant velocity, this is our first trip, and this is our second trip, and finally we come back. Let's analyze each motion. This is our first motion, and this is our second, and this is our third motion. Let's analyze each one, and let's remember velocity is constant during the motion. Okay, velocity is constant during the motion, and this is our first motion, second and third. So let's analyze each one. Let's look at the motion one. Motion one start from 0 to positive 100. Okay, so let's look at the position time graph. When you look at its position time graph, it is like this, because first position is 0 and last position is positive 100, and we can say that this is the time. So this is the time and displacement graph. So let's look at the velocity time graph. When you look at the velocity time graph, its direction is positive, and velocity is constant. That's why its graph is like this. Okay, its graph is like this. Let's analyze the second one. Let's analyze the second motion. Second motion start from right now positive positive 100 is our first position, and minus 100 is our last position. So,
Excuse me, sir.
yes.
Shavina's in the waiting room. Can you add her?
Sorry, can you repeat once again?
Shavina, she's in the waiting room.
Okay, okay. Sorry. Yes,
Thank you, sir.
thank you. Okay. When you look at this second option, when you look at this second motion, our starting point is positive 100 and our final position is negative 100. So right now, let's use these data. Let's use this data. We know that this is our first position and we know that this is our last position. And for that position time graph, linearly it is like this. Okay, linearly it is like this. For that time, let's remember direction is negative. Right now direction is negative, and we can say that even if velocity is constant, because of its direction, its sign is negative. So that's why our velocity time graph is like this right now. Okay, this is velocity time graph right now, and it has a negative value like this. So let me show you the final motion. Let me show you the final trip. Okay, let's look at the final option. That time our first position is minus 100 and 0 is our final position. So you can say that for position time graph, yes, this is minus 100 and 0. So it's has a linear rate of change, as you can see here right now, and then that time direction is positive, final position is 0, first position is minus 100. In other words, the direction is positive for that motion. That's why its velocity time graph is like this. Okay. These are some options for a motion with constant velocity. And also, yes, Sanuka is here. Yes. And also another important point, yes, let's look at the other subject, motion with constant acceleration. As you remember, there are two kinds of acceleration. First one is acceleration, and second one is deceleration. Okay, deceleration. Uh, especially in Italian question banks or in question banks. As I see, firstly they write the question in Italian, and then translate in English. Uh, that's why sometimes they explain every motion with acceleration, even if it means is deceleration. They also explain it by the word acceleration. Okay, but the true form of that motion is acceleration or deceleration. But we can also explain it with increasing velocity or decreasing velocity. Okay, so in other words, if uniformly, if the motion is increasing uniformly, if the velocity is increasing uniformly, we can call it acceleration. If the velocity is decreasing uniformly, we call it deceleration. Okay. So it has an special formula like delta v over delta t. This is the velocity difference. This is the velocity difference, and this is the time interval. Time interval. Okay. So yes, let me show you once again the different options and different kinds of motions. Let me show you on the horizontal way. Okay, assume that this is an horizontal way in one dimension, and once again this is point 0, this is positive 100 position, this is the position minus 100. Okay, as you see, there are three different positions right now, and let me show you. Let's start the trip. Let's start the trip. Our first trip is from 0 to 100, and our second trip is from 100 to minus 100, and the last one is come back. Okay. So, yes, and for that motion, first option is there is first option is acceleration, constant acceleration, constant acceleration, uh, and with constant acceleration, in other words, uniformly increase velocity increase uniformly. Okay, velocity increase uniformly, and in other words, it is constant acceleration. So let's look at each option. Once again, this is our first option, second option, and third option. Let's analyze the first strip. When we analyze the first strip, yes, from 0 to 100. Okay, so let me show you firstly the position time graph and velocity time graph, and finally the acceleration time graph. Okay, this is displacement time graph, velocity time graph, and acceleration time graph. Yes, right now, position time graph is a little bit different. Firstly, velocity is increasing uniformly. That's why its graph is like a parabola. Okay, like a parabola. You know, we can also call it as the graph of a quadratic function, like a parabola. Okay, and an increasing parabola. Okay, an increasing parabola. Yes, as you know, velocity, and assume that initial velocity is also zero for that motion. Okay, it is also another important detail. You need to assume that first velocity, initial velocity is zero. Okay, so right now, and also motion starts from point zero. That's why its position time graph is like this. And if you look at the velocity time graph, it is changing linearly, right like this. And right now, acceleration is constant and positive like this, okay? So let's look at the other options. Let's look at the other options. Okay, when you look at the other options, yes, right now, our first position is positive 100 and last position is minus 100. That's why some points changing. Let me show you each graph once again. Position time graph, velocity time graph, and acceleration time graph. Okay, so yes, position time graph, velocity time graph, and acceleration time graph. So right now, our first position is positive 100, and our last position is minus 100. Okay, and be careful. Still, it is increasing. Okay, it is increasing, and that's why its graph is like this. That's why its graph is like this. Okay. So, velocity, the direction of the motion is from positive to negative. That's why velocity is also negative and increasing uniformly. Okay. And still it is same. Initial velocity is 0. That's why velocity time graph is like this. And with acceleration for the negative direction, its constant acceleration is negative and like this. Okay, it is negative and like this. Okay, so be careful, be careful. I would like to emphasize once again, it is the motion of constant acceleration. In other words, velocity increase uniformly. Okay, so let's check the last option. Let's analyze the last option. So for the last trip, for the last trip, okay, right now our first position is minus 100 and our last position is 0. Okay, that time, let me show you position time graph, velocity time graph, and acceleration time graph. So, yes, this is position and time graph, and this is a velocity and time graph, and this is the acceleration and time graph. So, right now, let's check this once again. Motion starts from 0. Our initial position is 0 and final position is minus 100, and still it is increasing. So its graph is like this. Uh, just a second, just a second. It's my fault. Just a second. Sorry. As you can realize, it is changing like this. Okay. It is changing like this. So this is our position time graph, and this is be careful. The direction of the motion is positive. That's why it is increasing uniformly through the position parts, and acceleration is also positive and constant. I would like to summarize. I want to summarize. If you take your notes, if you could take your notes, I would like to explain and summarize. Okay. Yes. Right now we can say that. We can say that. If the position, let me show you right now. Uniformly motion. Uh, acceleration. Okay. Right now, let's look at the acceleration. In other words, velocity increase uniformly. Okay. Yes, this is the position time. This is the position time graph. Okay. So it changes like this. Okay. It changes like this. Uh, the upper one is acceleration, acceleration, and positive direction. Okay, positive direction. Uh, this is once again acceleration. Motion is with acceleration, and direction is negative. Okay, so let me show you this deceleration. And also it's a velocity time graph like this. Okay, it's a velocity time graph is like this. Okay, uh, increasing increasing velocity. Okay, and position and direction is positive. Increasing velocity, position direction is negative, and this is the velocity time graph. Okay, this is the velocity time graph. So what about the deceleration? Let's look at the deceleration. In other words, velocity decrease uniformly. Velocity decreases uniformly. That time, okay. This is the position time graph once again, and this is the velocity time graph. Right now, uh, this deceleration and deceleration. Okay, let's look at the motion with deceleration. In other words, velocity decrease uniformly. That's why position and time graph like this. So upper one is the upper part of that graph display upper part of that graph shows the deceleration with positive direction. Okay, deceleration with positive direction, and the other parts, upper part and other parts, deceleration with negative direction. Okay, and as you can realize, if there is an deceleration, in other words, it means that our first initial velocity is different from zero. In other words, it has a first initial velocity, Okay, and then it decreases uniformly. So once again, we can say that deceleration, positive direction, velocity decrease, decrease, and direction is positive. Velocity, velocity decrease, and direction is negative. Okay, so yes, this is the in my mind. This is the good summarize of that subject nearly. Is there any question about the graphs?
No, sir.
Okay, okay. So yes, as you see here, today we could today I could explain the first part of the motion in one dimension, and I'm going to show you the different questions to solve that, to understand the subject. Yes, right now, let's look at the other type of question. Our second type of question is motion in two dimensions. Okay, but before motion in two dimension, I want to explain you also. I want also to explain you the vertical motion. Yes, free fall, especially free fall and projectile motion, horizontal motion, they are vertical motions. And first one is free fall. Free fall is a vertical motion. When you leave and when you leave an material from the air through the earth, it's fall down. When a material fall down with zero initial velocity, we call it free fall. For instance, okay, assume that there is a ball here and it falls down. It falls down from a cliff or into the air, no matter where it is. But if it is a free fall, its initial velocity is zero. And because of the gravitational acceleration or gravitational field strength, it has a gravitational force. And gravitational force exerted on that material, on that object. Okay, so so because of gravitational force, it fell down. It falls down. Yes. Uh, in addition to motion in one dimension, I want to also explain you some important formulas. For instance, once again, as you remember, velocity is delta x over delta t, and acceleration is also delta v over delta t. But I can also show you more complex formulas to help us for different kinds of questions. For instance, assume that you know the displacement, and displacement is also V0 times T, that displacement can also be calculated by this formula. From that formula, and we can mix different types of formulas, and in general we can say that the displacement is also initial velocity times t plus 1 over 2 times a times square. Here delta x is displacement. V0 is the initial velocity, and this is the time of travel. Okay, and this is the acceleration of the motion. Okay. Yes. Let's check another important formula. V square is V0 square plus 2a times delta x. If we don't know the time of the travel, especially we use this formula, and this formula includes the context of that formula is final velocity, and initial velocity, and acceleration once again, and delta x here is also displacement. Okay, displacement. These are important. More complex formulas. We can also use that formula at the same time. For instance, velocity is also V0 plus a times t. Okay. Yes, once again, this is the final velocity. This is the initial velocity. And this one is acceleration, and this is the time of the travel. Okay, time of the travel. So yes, I think we are ready to use that formulas. uh, as you see here, these are general formulas. For that. These are general formulas for that motion, and we can also use that formulas to calculate the some important variables for the motion free fall. Okay. Yes. As far as I see, we don't have enough time. Let's have a break, and then go on 10 minutes later with the second section. Okay.
Okay, sir.
Okay, sir. Thank you.
So,
Thank you so much, sir.
see you.
See you.
Bye.
No.